So was a delay. Okay, back with the basal ganglia. So last time we talked about the go area and the no-go area. Okay, action and inaction. And these are operating simultaneously, non-stop action here through these 5 subcortical areas. Okay, just remember, the input areas are the caudate. Remember, this is the midline here, okay? So this is one hemisphere and this is the other. So ipsilateral, contralateral, okay? So the caudate nucleus is here, and the putamen here. These are the inputs area, receiving inputs from basically the cortex. A lot of excitation here, okay? Then the relay stations in purple. Globus pallidus external, subthalamic nucleus, which is basically an assistant for the thalamus. The thalamus is a workhorse. And then the output areas in blue. Globus pallidus internal. Remember, the globus pallidus kind of makes a triangle. And the substantia nigra pars reticulata. This is GABA. Substantia nigra pars compacta is dopamine, both excitatory, D1 dopamine, and inhibitory, D2 dopamine. Pars compacta is a modulator. It intensifies, it amplifies the signals. Whatever the living organism is experiencing, this dopamine intensifies it. Pay attention to this. This is valuable. This is rewarding. This is worth doing again. Or this is bad. Avoid this type of thing. So we talked about habits, right? We talked about this. We extracted a specific cell out of here and highlighted it here. And then we zoomed in and extracted a specific spine from the dendrite right here. And a good way of thinking about this, I want to cover this now, is let's just say the most severe case of the basal ganglia being hijacked by habits and learning and so forth, is OCD. OCD is heavily involved with the basal ganglia. So this spine right here, okay, remember we talked about morphology and how these bigger connections, you think about morphology as you have a synaptic connection here, but they will grow in size. So it's grown. It's almost doubled in size right here. Okay? And the bigger one, the bigger connections will have preference. And we can think about OCD like this. OCD is, I need to draw this out here. OCD is cortico-striato-thalamic or thalamic. Sometimes it's thalamo-cortical. Cortico-striato-thalamo-cortical. Or sometimes it's just cortico-striato-thalamic. But this is a loop. Remember, we talked about, okay, remember, the basal ganglia is right through here. We got the thalamus, the caudate nucleus here, putamen, right? These are subcortical areas. With OCD, you might have a lot of connections, let's just say, right through here, the sensory motor, because a lot of habits will live here. We like to shift our things to here for the habits. This is the primary input area to the caudate and the putamen. Not the only one, but let's just say this cell right here from the putamen is receiving an axon. And this spine is receiving an axon from a cell right here. And it's sending down to the putamen. Okay? The instructions from this cell can't execute the motor function. So that's why the basal ganglia is recruited. Remember, all of our actions or movements are orchestrated through the basal ganglia, except for the reflexes. So this information coming down, each synaptic connection is building a little summary, and then it's overall building a story. All of these connections are coming together. All of these inputs, these neural correlates, are coming together to form a story that's very specific to the living organism. So this cell here that's sending its axon down is just carrying information. It cannot execute the function, the motor movement, the action. But this cell right here is saying, flip the light switch, flip the light switch, flip the light switch, flip the light switch. It can't flip the light switch. So it has to recruit the basal ganglia here. So let's just say a specific cell here in the putamen, let's just say it's this one, and let's just say this spine specifically is the one that receives the information to flip the light switch, flip the light switch. So this connection, this spine from this cell will say, okay, I can flip the light switch. It doesn't know any better. It's just responding to the information coming down. So it executes the light switch. It will orchestrate this light switch. And it's all happening within these 5 subcortical regions. The no-go side will suppress any other alternative function, action, movement, and this go side flips the light switch and then turns it back on probably, or off, whatever the sequence is for the OCD to have satisfaction. Flip the light switch again, flip the light switch, flip the light switch. This is all happening in the basal ganglia. And this connection saying flip the light switch is strong in OCD. So this input area that is happening right here from this cell will say, okay, I need to flip the light switch. It doesn't know any better. It doesn't care. These things are dumb. It has no value. Value is coming outside of that. Things like this dopamine, yeah, it helps carry value, and the ACC and so forth, which is here. There's various functions here that are providing inputs as well, context, to say, okay, that's valuable, let's do that. But with OCD, there's this hijacked, that cortico-striato-thalamic loop. So this is a good way of thinking about how powerful the basal ganglia are and these 5 subcortical areas here. These input areas, they don't care. They're just going to respond. This is how the brain and the central nervous system works. We just respond. We don't like to think about things.